Here is a matching type question on general organic chemistry. Study the items in both columns carefully. Try to work out the matching before we solve it together. Let us first understand the key concept here. Aromaticity after deprotonation. When a compound is deprotonated at an sp3 carbon, if the resulting anion, or in one case a neutral species, satisfies Hückel's rule, 4n plus 2 pi electrons in a planar, fully conjugated cyclic system, the deprotonated species is stabilized by aromaticity. Moving on to the next step. A. The compound is a cyclopentadiene derivative with A, CH is equal to Cn or is equal to CHCN, exocyclic group at the sp3 carbon of the cyclopentadiene ring. Deprotonation at the sp3 carbon of the 5-membered ring gives a cyclopentadienyl anion. The resulting carbanion has 6 pi electrons in the 5-membered ring, 4n plus 2, n is equal to 1, making it aromatic. Additionally, the Cn group further stabilizes the negative charge by resonance induction. This species is stabilized yes. B. Cyclopropene upon deprotonation at the sp3CH2 gives the cyclopropenyl anion with 4 pi electrons, 4n n is equal to 1, which is antiaromatic. This species is destabilized no. C. Cyclopentadiene, C5H6, has an sp3CH2 at C5. Deprotonation gives the cyclopentadienyl anion with 6 pi electrons, 4n plus 2, n is equal to 1, in a planar 5-membered ring, classically aromatic and very stable. Yes. D. Cycloheptadiene upon deprotonation at the sp3 carbon gives the cycloheptadienyl anion with 8 pi electrons, 4n n is equal to 2, which is antiaromatic. No. E. 2H pyren upon deprotonation at the sp3 carbon, C2, gives a delocalized anion. The resulting system would have 6 pi electrons over the ring, but the oxygen-lone pairs complicate full aromaticity. The pyrenyl anion is not classically aromatic in the Hückel sense. For a stable aromatic system, it does not achieve the stable aromatic configuration cleanly. No. F. The cyclohexadienyl cation, a rhenium-like, has a positive charge at an sp3 carbon. Deprotonation removes H from that sp3 carbon, giving benzene 6 pi electrons, 4n plus 2, n is equal to 1, which is the archetypal aromatic compound. This is extremely stabilized. Yes. Moving on to the next step. A, C, and F, 3 compounds. And for the final step. B gives antiaromatic cyclopropenyl anion, 4 pi E. D gives antiaromatic cycloheptadienyl anion, 8 pi E. E does not yield a classically stable aromatic anion. Therefore, the correct answer is count 3 items A, C, F. Therefore, the correct matching is count matches 3 items matches A, C, F.